Imagine you're building a modern dashboard or data-driven application and your users expect fast, intuitive sorting on every table column, names, prices, dates, even custom business statuses. But every time you reach for a third-party library, you're hit with hidden complexity, performance overhead, or the frustration of black box behaviors that just don't fit your exact needs. What if you could design your own sorting system, one that's powerful, flexible, easy to extend, and completely dependency-free? In this tutorial, you'll discover how to harness the JavaScript strategy pattern to create pluggable, modular sorting algorithms for interactive data tables. You'll learn how to architect a sorting framework that gives you full control, easily swap out algorithms for numbers, strings, dates, or custom logic, and adapt instantly to new business requirements, all without sacrificing performance or maintainability. We'll break down the core concepts of the strategy pattern, reveal how it empowers you to decouple sorting logic from your UI, and walk through real-world use cases, from locale-sensitive name sorting to price and date comparisons, to custom orderings like active, pending, archived. By mastering these techniques, you'll be able to build data tables that are not only lightning fast and robust, but also a joy to maintain and evolve. Ready to unlock a new level of front-end craftsmanship? Be sure to subscribe for more in-depth, practical tutorials that keep you at the cutting edge of modern web development. Imagine a bustling library filled with thousands of books, each meticulously organized on shelves. To help visitors find books quickly, librarians have devised different ways to sort these books, by author, by title, by publication date, or even by genre. The method chosen to sort the library depends on what the visitor needs at that moment. In software development, especially in interactive web applications, data tables play the role of this library, and sorting algorithms act as the librarian's sorting methods. The challenge, however, is ensuring that our data tables can adapt on the fly to different types of data and diverse sorting requirements, just as a librarian must switch between sorting by author or by title depending on the visitor's request. The strategy pattern is the architectural solution that empowers this flexibility. It's a design pattern that encapsulates different algorithms, such as sorting techniques, behind a common interface. This means that for every distinct way you might want to sort data, for example, alphabetically, numerically, by date, or by a custom business rule, there is a separate, interchangeable sorting strategy. Instead of hard-coding these algorithms into your data table logic, you create a modular system where each sorting method is a standalone component. The data table, acting as the context, simply delegates the task of comparing two rows to the currently selected strategy. This is akin to a librarian asking, "How should I sort today?" and picking the right method based on the visitor's preference. Why is this approach powerful for JavaScript data tables? It means you can add, remove, or modify sorting logic without rewriting or risking the stability of your core table code. If your application grows and a new sorting requirement appears, perhaps a complex natural sort for product SKUs or a locale-specific string comparison for international users, you can introduce a new strategy with minimal impact on the rest of your system. This ensures your data tables remain both maintainable and adaptable, ready to serve evolving user needs without bloating your codebase with third-party dependencies or tangled conditional logic. Consider a chef preparing a buffet. Each dish requires a distinct set of ingredients and a unique preparation technique, but the chef's workspace, the kitchen, remains unchanged. The chef simply switches tools and recipes as needed, enabling versatility and efficiency. In JavaScript, the strategy pattern brings this chef's adaptability into the realm of sorting data tables. The kitchen is your data table component, and each recipe is a specialized sorting strategy. One for numbers, another for strings, a different one for custom business rules, and so on. The brilliance of this pattern lies in its separation of concerns. The data table does not need to know the intricacies of how numbers are compared differently from dates, or how local sensitive string comparison works. Instead, it relies on each strategy to handle its specific sorting logic. For instance, sorting numbers requires careful attention to type coercion and edge cases like NaN, while strings may demand locale-aware comparisons for internationalization. Dates can introduce challenges with time zones and formats, while custom business logic, such as prioritizing active statuses over pending or archived, requires explicit mappings. By treating sorting strategies as interchangeable modules, you can register and select the appropriate strategy based on metadata in your column definitions. This is much like the chef picking the right recipe card from a stack based on the dish ordered. If your application's requirements shift, say, you now need to support right-to-left languages or sort by a dynamically computed relevance score, you only need to craft a new strategy and plug it in. This modularity not only streamlines maintenance and testing, but also enables code reuse across different tables or even projects. It future-proofs your application against the ever-changing buffet of user requests and data complexities, ensuring that your data tables remain robust, scalable, and user-friendly. This is the data table component, the core context that manages, displays, and sorts tabular data using pluggable sorting strategies. It delegates all comparison logic to strategy instances based on the column type, toggles ascending, descending order, and renders the HTML table with interactive sort buttons. This is the central registry for all available sorting strategies. Each key corresponds to a data type or custom type, providing a mapping to the correct strategy instance for use within data table. This defines the abstract sort strategy interface. All concrete sort strategies inherit from this class and must implement the compare method, which takes two values and returns a number as per JavaScript's comparator protocol. This is the numeric sorting strategy, handling columns whose data is numeric. It converts both values to numbers and returns their difference. This strategy implements locale-aware string sorting using NTL collator for proper comparison according to language and sensitivity options. This strategy compares date values by converting each to a JavaScript date object, enabling chronological sorting. This is a custom sort strategy for fields with a specific predefined order, such as status. It uses an order array to determine each value's sort position. This column definition file specifies the metadata for each table column, including its data type and whether it is sortable. The type is used to select the appropriate sort strategy. This file contains the sample data used in the interactive table, with various types for testing all strategies: strings, including diacritics, numbers, dates, and custom statuses. This is the main entry point. It sets up the data table, binds it to the DOM, and wires up event listeners for sorting and resetting. This is the HTML file for the front end. It provides a container for the data table, a reset button, and loads the JavaScript entry point as an ES module. This is a test file for the sort strategy classes. It verifies correctness for numeric, string, locale-aware, date, and custom order strategies. This test file provides end-to-end testing of the data table sorting logic, ensuring correct sort order for each column and direction. This is the package manifest. It defines the project metadata and scripts for running and testing the table application. The interactive data table appears on the page, fully loaded and ready for user interaction. The table displays columns such as name, price, status, and SKU, each with clickable headers for sorting. The demonstration begins by sorting the data by the price column. When the price column header is clicked, the table immediately sorts the rows in ascending price order. All visible rows rearrange accordingly, presenting the lowest price at the top. The sort button or indicator on the price column reflects the active sort state. Clicking the price column header again reverses the sort order. The table now displays rows in descending price order, with the highest prices at the top. The visual indicator on the column header updates to show descending order. Next, the name column header is clicked. The table sorts the data alphabetically by name using locale-aware string comparison. Entries with diacritics or special characters, such as those including accented letters, are sorted accurately according to locale rules. The table visually updates, and the sort indicator moves to the name column. The status column header is clicked, triggering a custom sort. The table reorders rows based on a predefined status hierarchy. Entries marked active appear first, followed by those with pending, and finally, archived. This custom order is immediately reflected in the arrangement of rows, and the status column visually indicates the sort direction. To demonstrate compound, multi-column sorting, the status column header is clicked again, toggling the sort direction for status. While holding the Shift key, the price column header is clicked. The table now sorts first by status, then within each status group by price, combining both sorting strategies. Rows grouped together by status, each subgroup sorted by price. Continuing the compound sorting, the name column header is shift-clicked. The table further refines the order. Within each status group, and then within each price subgroup, the data is sorted alphabetically by name. The multi-level sorting sequence is reflected in the UI, with indicators on multiple column headers. To reset the sorting and return to the original data order, the Reset Table button is clicked. The table instantly reverts to its default unsorted state, and all sort indicators are cleared from the headers. The Show Test Panel button is clicked, revealing a dedicated panel on the page that displays automated test results. The panel lists individual test cases, their pass-fail status, and possibly brief descriptions. All displayed tests pass, confirming the robustness of the sorting strategies. The demonstration continues by interacting with the SKU column. Clicking the SKU header sorts the data based on product SKU codes, which are visually styled in a code-like format. The table updates to reflect the new sort order. For accessibility, keyboard navigation is used to focus on the Created At column header. After tabbing to the desired column, pressing the Enter key activates sorting on the Created At column. The table sorts the rows by their creation date, and the change is reflected both visually and in the sort indicator. Finally, the page scrolls smoothly down to the footer, allowing the viewer to see the entire data table and interface elements, concluding the demonstration. With the strategy pattern in your JavaScript toolkit, you're now equipped to build data tables that sort any way your users demand, without waiting for a library to catch up or wrestling with black box abstractions. You've seen how pluggable sorting strategies unlock flexibility, boost maintainability, and give you direct control over every aspect of your front-end data experience. Imagine how much smoother your next dashboard, catalog, or analytics tool will be when you can introduce new sorting logic in minutes, not hours. Whether it's locale-aware names, custom business rules, or blazing fast numeric sorts. If you're ready to keep sharpening your skills and want more practical, real-world patterns that save you time and headaches, make sure you subscribe. Every video is packed with actionable techniques that make you a faster, more confident developer, so you can deliver features your users love and your team depends on.